All right, first form. So what we've talked about so far was standard form, right? Ax squared plus bx plus c. So there are two other forms. And I'm going to list them here for you, and then I'll talk about each one. The first one is vertex form. And it looks a little different. A lot different, actually, right? The only thing I see that it still has that the other form has is what? The A, right? Good thing for us, the A still does the same thing that it did in standard form, okay? Up, down, skinny, wide. But outside of that, it's a whole new form, but I think you'll like it. I think it'll probably be your favorite. The other is intercept form. And the names of these forms tell us what they give us. Again with the A here. And luckily that A, again, does the same thing. Up, down, skinny, wide. Okay? What else can it do? That's all it does. It shrinks and stretches and flips it. Vertex form gives us the, guess what? What do you think? The vertex. Intercept form gives us plus this time it gives us X-Intercepts. I see two sets of parentheses there. Can you think why you might have two X-Intercepts? Yeah, think about the way the parabola looks. A parabola can do this, so it would have two X-Intercepts.
So it's not symmetrical?
Yeah, it's still symmetrical. Still the same parabolas. This is just ways we could change it and rewrite it to a different form. All right, so let's focus first on vertex form. I think you're going to see this and go, why didn't you show us that first? All right, so we've already said that A tells us up, down, skinny, wide. Do I need to go back over that for anybody? We remember. The bigger A gets, the skinnier the graph gets. The smaller A gets, the wider the graph gets. Positive is up, negative is down. The additional information here is the H and K. Together, HK makes up my vertex. There's no opposite B over 2A. There's no plugging back in for the vertex. I just literally pull the vertex out of the equation. Okay? Because there's a minus sign, however, in front of that H, the H is the opposite sign. What? Who taught you this? I guess maybe y'all might have at the very end.
No, it's the same thing except there's no P and Q.
No, it's not. I'm pretty sure it's not.
Exactly. So did y'all hear the question? If this was X plus 2, then the H would be negative 2. If this was X minus 2, then it would be positive 2. Okay, so it takes on the opposite sign. The other thing I want to tell you before we dive right into graphing is that if they're missing, if H or K are missing, what value do you think they take on? 0. Well, it could be, but then if they're both missing, it's really a standard form equation because it would just be ax squared. But if you think about ax squared, like what we did in our warm-up, 2x squared, the vertex was 0, 0. That's right. Nice connection, guys.
Wait, so it all depends on the H, whether or not the H is positive or negative? Oh. It's like whenever they switch? Like
well, the H takes on the opposite sign, but the K keeps the same sign.
Always.
Always.
So K is always...
K is whatever it is, and it sits on the end outside the parentheses. So I'm going to give you a couple examples and let you see what I'm talking about. If I had 1/2 x minus 1 squared plus 3.
It'd be
The vertex
1,
is,
3. 1, 3.
say again,
1, 3.
1, 3. Opposite same.
Oh,
Okay, so it just tells us, and we pull, yes. So it eliminates, remember when we're graphing in standard form, we do opposite b over 2a, we plug back in, it eliminates that whole first step.
Well, isn't the whole point just to find the vertex though? In that equation?
Well, but then we'll graph. So we'll still need our
okay.
easy point, and we'll still need to reflect, but that whole first step, gone. Which was the hardest step in graphing, I think
Yeah.
we would all agree. How about there? What's the vertex? 5, 0. And then just like y'all were saying on the one from the warm-up, if you had like negative 2x squared, well then in this case, 0, 0. The h and the k are missing.
Well, how would you know that that's just not like a standard?
You could do it either way.
Okay.
Because instead, y'all did it in standard form and as warm-ups, and it came out the same way.
Yeah.
All right, y'all ready to graph? You want the step chart or nah? Do you like the steps or no? Yeah. Okay. All right. How to graph in vertex form. And we'll pause. Step 1. Plot the vertex. The vertex is HK. H is opposite, K is the same. So I heard 3, negative 5. Perfect. Is anybody confused on step 1? Okay. Let me see. Okay, so that point was 3, negative 5. Over 3, down 1, 2, 3, 4, and 5. There's my vertex, which is also my what? What goes through the vertex? Line of symmetry. Great job. Yes, no, maybe so? Okay. So now, if you learn to graph in standard form, your steps are exactly the same at this point. Your steps 2 and 3 are the same. The only difference is when I find my easy point, I don't have a y-intercept to use this time. Okay? To find the y-intercept, I'd have to actually FOIL this out, multiply, simplify to find what it was. So that's no longer an easy option. So what I always do is just what you were doing before when you couldn't use the y-intercept, which is pick one close to the vertex. I usually take that h and add 1 to it. So 4. Does that make sense to you? Stick close to the vertex. Because remember, the further away from the vertex I get real high or real low real fast.
Wait, you said you take H?
I take the h that I started with and I just add 1 to it. I just move. In other words, okay, so look at the picture. This, I just go 1 over from it. So this was 3, so I'm going to use 4. Just because it's close. Use 0. Use whatever you want.
Yeah, but I mean, how do you find that? How are you picking that without like?
You can pick any number you want.
Yeah, you can pick anything you want.
It's just easier if you pick one smaller.
Does that make sense? No? Yes? I just stick close to this.
Well, once you pick the X,
What do you do? How do you find the y that goes with the x? You plug it in. You could have done, yes, you could have done 2. You could have really done anything you wanted. This makes it nice too because when you stay close to the vertex here, you usually get 1 in parentheses. So I get 1/2 times 1 squared minus 5, which ends up being a half negative 4.5.
Yeah.
Does that make sense? Am I going too fast? You can't see. You see it now? Can you see it right? All right, so I'm going to plot for negative 4.5. I'll give y'all. All right, 4, 1, 2, 3, 4.5. There's my easy point. What do you always do next? Reflect. Reflect and connect the dots. Reflect, connect. What you think? Easy? Easier than standard form?
Yeah.
Good. I will tell you to be very careful if you choose something that's not right beside the vertex for your easy point, because when you plug in this formula, you got to watch your order of operations. So you'll subtract first, square what's in parentheses, and then multiply by the outside, if that makes sense. All right, here's the graph. Let's do domain and range real quick. What's the domain? Negative infinity to positive infinity. What is the range? Close. What's the lowest point on the graph? What's the lowest it goes down to? -5 with a bracket, and it goes up to, and will you put that away for me, please? Whatever's going on it. Yes or no? Do you have games loaded on that? Because this may help you. Listen, the question was about range. When you're looking at range, all right, we know the domain is always what on quadratics?
Negative infinity.
Negative infinity to infinity. But the range, if it's going up, okay, so we're going to call this HK. Then the range is H to infinity. K, I'm sorry. Because it's Y. And if it's going down, then the range is negative infinity up to K. Or the Y part of the vertex. A little harder.
Is it harder than the first one?
No, nothing's harder than that.
Oh, really?
No, that's the hardest form. All right, so intercept form, I told you looks like this. My A still does the same thing. Up, down, skinny, wide. This time, the P and the Q, and again, because there's a minus sign in front of them, I'm going to take the opposite signs. X equals P and X equals Q are my X-intercepts. I'm going to just put INT, but with the opposite sign. Now, what if one of them is missing? 0.
Wait, so wouldn't, if one of them was like something, then wouldn't the other one have to be a mirror with the vertex of the other one?
Well, that's a very good point, and we're going to use that concept to find the vertex. You're absolutely right.
Oh, yes, I'm
It's because it's symmetrical. That's going to help us find the vertex. Good job, guys. I'm impressed. This time I'm going to have to use what they give me, and I'm going to have to work backwards a little bit and kind of think through this. So the first thing I want to do is plot the X-intercepts. Which is P and Q. Opposite signs, though. So, yep. So in my example equation here,
So it's gonna be negative 3, 1.
yes, exactly. It's going to be -3 and 1. Does that confuse anybody? Everybody okay on that? All right, I'll give you a second to copy that before I graph it. All right, I'm not going to set up the grid for the sake of time. -3. -3 and 1, not -3, 1, but -3 and 1. They're the X-intercepts where it crosses the X-axis. Does that make sense? Okay. Looking back, should it open up or down? Up. Why? It's positive. Now here's where you have to think, and y'all were right on the brink with this earlier. If a parabola is symmetric and you have 2 points on the same horizontal line, then the vertex is going to happen where? In the middle. So now the question is, and I know you could count this easily, but in general, how can we find exactly in the middle of 2 points?
Midpoint formula.
Oh, good job, midpoint formula. But since the y's are 0, I can really just do the midpoint of the x's, right? So whenever you find the midpoint of the x's, what do you do? Average them together. That's all you're doing is averaging together to find the middle. So, first thing I'm going to do is find the axis of symmetry, because that's going to be in the middle. And so y'all said you average them together, and you're right. Oh. So over here, my axis of symmetry is going to be -3 plus 1 divided by 2. -2 over 2, which is -1. Is anybody confused by that? You could easily look at this one and count, but you'll have some that may be fractions or decimals. You'll really need to average them together to find the middle. This one was an easy average. So -1 is my axis of symmetry. So now the question, and this is really the hardest part of the problem, is how do I find where on that axis of symmetry the vertex occurs? You do what? Yes, y'all know this. Come on. This is the axis of symmetry. The axis of symmetry, exactly. The axis of symmetry is also the x coordinate of the vertex. If you have the x part of the vertex and you want the y part, you just plug it in, just like you did before. Plug it in.
You plug in the axis of symmetry.
Wait, so X
Yes, you plug in x is -1. So now I'm going to use that -1 and plug in my original equation. And I'm going to work through it. Again, this is the hardest part of intercept form right here. And that's still not as hard as opposite b over 2a and plugging in, right? Come on. No. No, Miss McGee, it's not. Thank you. I agree. I got -8. What did you guys get? So what are the coordinates of my vertex here? -1, -8. -1, 1, 2, 3, 4, 5, 6, 7, 8. Is it opening up? Yes. Does that make sense to everybody? How about the domain? Always, every time. How about the range? -8 with a bracket. A positive. Tell me.